Welcome to The Explainer. Today, we're diving into a really radical new theory of everything, and it comes from the work of an independent researcher, Mohammed Noordin. It's a vision of the cosmos that might just challenge everything you think you know about where it all came from.
We've all heard the story, right? Our universe just explodes into being from an infinitely dense point. But what if that wasn't the case? What if the origin of everything was, I don't know, quieter, more structured? What if it wasn't built from a physical explosion at all, but from pure information?
So, this new framework is called the First Quanta theory, and it suggests that the universe we know is really just an emergent property, kind of like a bubble forming inside a much larger, timeless reality. Now, that's a pretty bold claim, so let's unpack how it's supposed to work. To really get our heads around this new origin story, we have to go back. No, not just to the beginning, but to whatever came before the beginning. Okay, so instead of a single point, I want you to picture a boundless, timeless ocean of pure energy. This is the primordial state, and it's not empty, not by a long shot. It's filled with these fundamental units of information called nodes, all in a state of perfect, chaotic balance. There's no time, no structure, just pure potential. And here's the core idea, something called information mass. In this theory, the physical mass that we experience, it isn't fundamental. Instead, every single node has a value that represents its pure informational content. And from this one property, everything else we observe, gravity, charge, even physical mass itself, it all just emerges. So, if reality starts as this timeless sea of energy, how do we get a universe with stars and planets and, well, us? The theory proposes it didn't start with a bang. It started with a pop, and this is the big pop. First, you have that high-energy primordial state. Then, a random fluctuation causes a bubble of low-energy space to just form within it. And that bubble, that's our universe. And crucially, the high energy right there at the boundary of this bubble is what kickstarts the creation of matter itself. Now, this is really important. This new vacuum isn't a void. The theory describes it as a structured physical medium, a fabric that's woven from what it calls energy quantum knots. Think of it like a flexible lattice that can be bent and stretched, one that can store energy in its tension. This is the stage upon which matter is about to be born. So this brings us to the most specific part of the theory. How does this energetic vacuum actually create the particles that make up everything we see? At the high-energy edge of our universe bubble, raw heat energy gets compressed by the vacuum structure into these tiny, localized wave packets. The theory calls these EM springs. Just imagine coiling pure energy into a tight spring ready to be released. And this process is particle genesis. An EM spring forms and travels inward, uncoiling and losing energy as it goes. Think of it like a radio dial turning. If its frequency happens to hit a perfect station, a natural resonance of the vacuum, the energy stops dissipating, it locks in, and becomes a stable particle, a quark. So how likely is it for one of these energy springs to lock in and become matter? This isn't just a vague idea. The theory simulations calculate the probability. For a down quark to form, the chance is just 2.3%. It suggests matter isn't an inevitable explosion, but a rare, probabilistic outcome of energy finding just the right frequency. Okay, so particles can pop into existence from pure energy. But that still sounds pretty chaotic. What ensures this process creates stars and galaxies instead of just random static? This brings us to the theory's guiding principle. So how does the universe know what to become? If the formation of particles is based on probability, what prevents total chaos? The answer, according to the First Quanta theory, is a cosmic set of instructions. The theory incorporates a version of the holographic principle. It proposes that the evolution of our entire universe is guided by a holographic blueprint, a master equation that contains all the rules for how order emerges from chaos. And this master equation is versatile. You can express it in 3 different languages. The information form views the universe as a computer, always working to reduce uncertainty.
The physics form describes how objects follow the path of least resistance or least action. And the communication form describes the quantum connections between all its parts. 3 different perspectives, all describing this same single underlying law.
And this is the really profound implication of that communication form. The theory posits that every particle inside our universe has an entangled twin on the surface of our cosmic bubble. This connection is constantly updating the universal blueprint, guiding the entire cosmos on its path from chaos towards greater order. It's a living, dynamic instruction set.
So what does it mean to live in a universe governed by a holographic blueprint? Well, it fundamentally changes our view of the cosmos and our place in it. The standard view often portrays a universe evolving randomly, driven by chance collisions. But this theory suggests a guided evolution. The universe isn't just expanding, it's developing, driven by an innate tendency to increase its own informational complexity and order, following the rules of its blueprint. And this leads to the theory's most powerful unifying claim. The reason a ball rolls downhill, following the physical path of least action, is the very same reason a system organizes itself into its most stable, ordered state. It means the laws of physics and the rules of information aren't 2 different things. They're just 2 languages for the same fundamental drive toward order. Ultimately, the theory leaves us with this. Through its holographic link, our finite universe remains connected to the infinite potential it came from. Our reality isn't isolated. It's part of a grand informational feedback loop. And that leaves us with a final question. If the universe is a computer, what is it trying to solve?